Hi everyone, welcome to the MathSpellBook livestream. I'm your host Peter, and basically we are going to get back into a little bit of our practice with proofwriting. Maybe we'll also do some maybe a little bit of research in physics, but well, not research, but more like a study in physics. I say research because usually for me it's mainly just looking through books and all that stuff. Anyway, let me just get everything set up here, because we already have Sascha's worksheets here. There's something else in my file that I want to open. Let's see here. I was actually reading this one book, Graduate Mechanics for Non-Physicists. I think it's a really good book. I'm in chapter 3 somewhere. Felt like I probably should just read up a little bit on that. How you guys doing? It is Monday after all, so hopefully you guys are having a good Monday so far. Let's see. So we were working on this one, exercise 2, that Sascha presented to us. So we have to prove that this has a left inverse. So I think Sascha gave an example of how this would look like. Okay, so, or how he basically said that what we have is a little bit easier than what he wrote, so I'm just basically going to read through it here briefly. Let me see here. I just want to check that everything's good. Okay, my mic is working. Good. Okay, so let f go to a and to b be a function between two non-empty sets. We will show if f is injective, then there exists a g of function g where it goes from b to a, such that I think this is the composite. Composite from g to f is the identity of a. And I think we can also have the book. Let's see. Because I think this will also help us. Look up proof. Let's open this. There we go. And I think we have to go into functions. Because I know there was a section on composite and injective and subjective, surjective. So let's take a look. This is how usually I operate sometimes. I just basically find something that I recognize. I'm like, oh, gotta flip the book, flip open. Let's see. This is just basically functions, right? What's a function? Yeah, functions. This is functions. Let's see. We have domain. 2 functions. A to G, A to D are equal if G has this. Oh, interesting. So 2 functions f from A to B and G from A to D are equal if f equals G as sets. Equivocally, f is equal to G if and only if f of x is equal to G of x for every x in A. Okay. So, oh, here we go, subjective. And so basically the definition, a function of f of a is injective or one-to-one if all a prime in a is not equal to a prime, implies that f of a is not equal to f of a prime. That's sure, that's obvious. and I'm using sarcasm with that. Surjective, or on to b. For every b in b, there is an a with f of b is equal to f of a is equal to b. And bijective is both subjective and objective. Okay. I'll be right back, guys. I just realized I forgot to fill my water bottle. Alright, we're back, guys. Sorry about that. Anyway, let's get back to it. So according to the structure, how to show a function a from f from a to b is injective. So we have the direct approach and we have the... Oh, okay. So at least we start out with this, and to show something surjective, suppose, okay, I think this will help us. So, alright, so we have to show that f, so, let's see. Oh, oops. Maybe we should move this up here, so I can just easily access it. Oh, hello, Benakuref? Hopefully I'm reading that right. On the Luffy book, exactly that theorem. I proved that. I'm pretty sure you're way smarter than me then. Like, hopefully I'm pronouncing that right. Kuraf? Is that how you pronounce your name? Hopefully I'm pronouncing that right. If I'm not pronouncing it right, please correct me. But how are you doing? How are you doing? It's Monday, so I'm pretty sure. Benetsaraf. Is it okay if I call you Benna or Bennett? Just to shorten it a bit. I just want to make sure that I call you by a name that's comfortable for you. Like, I'll try my best to pronounce your full username, but at the same time, it's like, I feel like I should shorten it so that, like, you know, our communication on the chat is, much more fluent. So what are you up to? Are you getting some studying done yourself, or are you just basically just tuning in for the maths? Okay, so according to this, so let's say let A and A prime be elements of A, and f of A is equal to f prime of A. I think that's what they showed in the example, right? Yeah. There, and we have to prove that therefore A and prime of A are equal. Because according to the book, it basically says that to prove something is injective, it's easier to do contrapositive, proof by contrapositive. Okay, so we'll just write the last part, therefore A is equal to f prime. So let A and A prime be an element of A, and f of A is equal to f of A prime. Okay. So now, let A and A prime be an element of A, and so that means there exists an A in A prime, an A such that f of A is equal to A prime. So now we have to show that therefore A is equal to A prime. The question is that how do we do that? Why don't we write that A? Didn't look that great. There we go. There exists an A in A such that f of A is equal to f of... Maybe we have to use B in this case. Because there exists an... No. I feel like this proof is like... So let A be an A and A prime in A, and f of A is equal to f a prime. So the question is, how do we show that A is equal to A prime in this case? Do we use... Oh, maybe we can use by definition of pre-image. Oops. Let's see if this works. A pre-image, A is equal to f of A is equal to the inverse of f prime is equal to just want to move this a little bit right here. Okay, so so A is equal to F of A, and now is that enough to actually prove that they are equal to each other? I mean, it is? Okay, okay, Bennett, thank you for clarifying that. That was actually... Right, A is equal to A prime? Okay. If you said it, then I'll just write it. You're definitely smarter than me. You're basically helping me make the proof look more legit. And I appreciate that. That's why I like it when you guys are talking in the chat, because it's like you help me become smarter. I probably shouldn't say that. It's like you help me become more educated. Because I believe we help each other. We help each other to be better educated in what we want to get better at. Let me just do this, move this here. So I guess we'll just make the little cube. Therefore, A is equal to A prime. Okay. Well, I'm glad I got your stamp of approval, Bennett. Always appreciate your help. Okay. I mean, the form... A prime... Gotcha. Yeah, that actually probably makes it much more... That's actually probably easier to read, actually. I will go with your advice. And actually, that does look cleaner when I think about it, yeah. So, F of A prime is equal to F of A F of A. Yeah, I think that probably might look cleaner. Because it actually works both ways. It's not like very wordy. I actually like that suggestion. Actually, Bennett, do you mind if I ask, like, are you a university student? Are you a grad student? Or you just love math and you're just teaching yourself math? Or are you in high school? Oh, okay. Yeah, let's bring more structure. Let's bring more structure. You're right. Yeah, it would probably look nicer that way. Because it gives us more of the outline. So, but then again, we have it here. University student, 2 semesters start. Oh, okay. So you could probably teach me some physics too, actually. Like, the thing of it is that I haven't taken a formal class in physics, but I did take an online course on like physics for like engineers and scientists. Not really targeted for physics majors, but mainly for, like, you know, the typical basic physics course. I don't remember anything beyond like potential and kinetic energy. And like entropy and all the fun stuff, I don't even remember that much. I do remember some bits of like general relativity. if you have to prove that f it has a left inverse, then f in injective, you can't use that f is injective. Then f is injective, and you can't use the. Oh, you're Russian. Okay, that's fine. Actually, there was like a translated book from Russian that I was trying to use to learn mathematical physics. I only know like multivariable I only know like calculus 1 and 2, like integration and differentiation. But I haven't learned like multivariable calculus yet. I'm trying to teach myself math. I'm not like in university or anything. I do math as practically a hobby because I also want to learn physics. Okay, so this is not the way to prove it. It's just to prove that it's injective. Okay. Okay, so I guess maybe this is not the technique we have to use, right? I mean, does this book cover what it means to be a left inverse? Oh, maybe it's an inverse, this inverse section, because there is inverse in here. I remember that. Maybe I took the wrong proof technique. Okay, inverse functions. Here we go. You may recall that from calculus. For set A, the identity function. Okay, yeah, here we go. For set A, the identity function on A is the function from A to A defined by. Okay. Let's see. Oh, what'd you type here? Contrapositive form is the same as but the other but from the other point of view. Oh, okay. Interesting. Let's see. If f is bijective, then then its inverse is okay. Did they define like what's left inverse and what's right inverse? It seems like they don't cover what it is, unless it's further in here. No. Actually, this section is relatively short. Huh. There's nothing about left or right inverse. Let's see. F A from A to B is bijective, then its inverse is the function, right? Yeah. And obeys the equation. So, okay. Maybe Sascha's like notes will let us know about that. Okay, so let f be between two non-empty sets. We will show if f is injective, then there exists a function g from A to B such that. Okay, this is like the composite result. Okay, f has a left inverse. Okay, so I mean, this is the definition, I think. Yeah, because let the two empty sets, we show that f is injective. Okay, so we have to actually show that it actually has the inverse. Well, that's like partially what I get from that. Like A prime is not equal to A, but we can write it's like, yeah, I tried to do it in the counter positive way, because I think like what you're saying is the direct proof way, where you basically give it the define, you define it in that way. Where is it? Here it is. Like suppose that, and then A is not equal to A prime, and therefore f of A is not equal to f of A prime. Because I think in the book they recommend this one because it's a little bit more, it's a little less writing than this one. I think you have to write more with this one. You have to prove one, which is left inverse. We get the statement that f is injective, right? So I guess I guess I used the wrong proof technique then. So I guess it's not this. That's what I'm guessing you're saying. Because yeah, it's like you said, we have to prove that it has a left inverse and therefore f is injective. Yes, it's how we have to show the function is injective, but to show this we need to know what the function is, what function is injective. You need to start from define of the left inverse. Okay. So this book is not telling us what the left inverse is. Sascha pointed out in his notes that we have to have an inverse. Yeah, let f and b be the function between two non-empty sets. We will show if af is injective, there exists a function such that, okay, there's the identity of a. Okay, proof. Recall that. Okay, so this is the definition of an inverse. Consider a set S, which is like this. Okay. The claim is a collection of non-empty sets. F prime. No, f of the inverse of y is an equivalent. Is the image of f. This there exists x and a, so thus is not equal to the empty set. By the axiom of choice, there exists thus the choice function as an empty set. Claim. Okay. I mean, that looks pretty long, but at the same time, like, proofs are probably getting longer and longer the more you get into it. So I guess I have to erase this because I don't think it really does. It just proves that f is injective, but it doesn't really show that it has a left inverse. So guess we're gonna have to go back to the drawing board. I mean, at least I'm able to prove something is injective. That's something, right? Prove a function is injective, at least. Gotta give myself a pat on the back for that, I guess. Okay. Alright, so now we gotta figure out function g and b is the left inverse of f of a to b if... Right. Now the question is that how do we actually, like, write that nicely as a proof? Because I'm guessing this is just the way that it's defined. So for proof, let's see, recall that y. So consider this. I use that to prove. Oh, okay. So you, hey Sascha. We're actually doing exercise 2 of your first sheet. I thought I had it, but then it turned out it wasn't the right approach to do it. I was able to prove the function wasn't was injective, but I didn't prove the left inverse. So I was like, oh wait, no, this is not it. I proved that the function was injective, but I didn't prove that it was had a left inverse. Okay, so according to Bennett, we have to, what you suggest is that let G be a function from A to B is left inverse of f from A to B if is equal to, I'll just put I for identity of A. So what's wrong? You're given that function has a... Okay, so before we actually try to attempt to do this correctly, so what I did is that I looked into this book that I usually use to read whenever I learn proofs, the book of proof. I use this approach to actually just prove that the function was injective. Like I use this type of structure. But I realized, thanks to Bennett, I realized that I did not prove that the function has a left inverse. I did not prove that. So I feel like I have to like go back to the drawing board to actually do this proof correctly. You don't have to prove that it's a left inverse. You have to prove that the statement has a left inverse, right? Yeah. And thus implying that it is injective. You already have the function that has the left inverse. You have to prove that the function which have a left inverse is injective, right? Right. So let G be a function from A to B. Is the left inverse of f from A to B if if is equal to the identity of A. Okay, now the interesting part. Filling out the middle. Probably I should also write in the bottom, therefore f is injective. Okay, now to fill in the middle. Write the definition of injectivity, it might help you. Okay, let's see. Just want to make sure if there's like, just want to see if there's like if Sascha wrote a better definition than what I was going to find. injectivity in this book? They probably don't. I'm guessing they probably don't. And they give the identity function. So let's see. Set A, the identity function of A is a function that defines A to A as identity of A, X is equal to X for every X in A. So maybe I have to go on Google to like look that up. Google mathematical definition of injectivity. Definition 12.4. Theorem. Pigeonholed. 12.4. Thank you for that, Mandan. How are you doing, actually? Sorry I didn't greet you in the chat. Okay, here we go. Oh, just write the definition for injective. That's what you meant. Okay, I thought injectivity was a different type of word, a different type of definition. I mean, okay, so maybe we will write that because we all have to rely on definitions actually. So the definition of injective, or I think it was 1-2-1. Let's write that. Yeah, 1-2-1. Actually, I probably should have done this. Yeah, I should have done that. That is much easier to do. Copy that. Let's erase this. I didn't have to write that down. I just gotta copy that. Okay, paste. Yes, please allow, please. There we go. Nice. That looks much nicer. Use control write and write what you find in the book. Yep. I'm good, enjoying the stream. Okay, good. Because, like, sometimes I worry that you guys are not enjoying the fact that I fumble about whenever I learn stuff. So I'm glad you're enjoying the stream. Okay, if all A and A prime is an element of A is not equal to A prime, implying that f of A is not equal to f of A prime. Okay. So let G be a function from B to A and is the left inverse of f, which is a function from A to B, if the composite. Okay, so maybe we have to look up what the composite definition is so that we can have all the pieces. And also I probably should take the definition of identity too, since this seems to be like part of it. I know it might not be necessary, but I feel like I should have all the definitions that I can use. Copy, then paste. Nice, it appeared where I wanted it to. Okay, so where's composite? The inverse relation. Actually, I probably should like copy some of these definitions here. I feel like they could come in handy. Like my brain works like in totally like usually I have to have things like in a little bit of a mess before I actually start assembling pieces together. Bijective, I don't think we need that right now. Where's was something about composites here, like composite functions. I want to make sure I have that because I know it's part of the inverse. Here we go. There it is. That's what I'm looking for. Okay, copy. And let's paste this. There we go. Okay. So suppose that f of a and g of a are functions that can be f from a to b and g from b to c are functions that the property of the co-domain of f equals the domain of g. The composition of f with g is another function denoted by if f in a, then therefore sends the elements of a to elements of c, and the composition. Okay. Control F, then enter. It's just faster. Oh, is that like basically a shortcut? Is that? Oh, okay. Yeah, I always forget that shortcut. Yeah, Control F and then basically type in what you need to search for. Okay. So, okay, we got our definitions here. Now we just have to find a way to fumage them together. So maybe in this last part, by definition of an injective function. I just want to write that because I feel like it's going to be part of this bottom half to make it look nice. Now apply the definition of the left inverse. Okay. By definition of the left inverse. Given the relation R, A to B, the inverse relations of R is the relation of A and B defined as R. Okay, in other words, the inverse of R and relations and interchange. So suppose that our functions, the composition of be written, denoted, defined below. Let's see, if x, didn't mean to do that either. Do we have an undo button? We probably don't. Oops, didn't mean to erase that. Actually, I still have it there, so actually we can just copy from there. I forgot that I still have the little box. There we go. That's back. Okay. So if x in A, then so maybe we have to write that. Maybe we don't. Do we need this? We probably don't need this line. Maybe, I don't know. X is an element of A, and how I wrote that then there. Yeah, that's better. It looked like it said thin, and I was like, oh, that doesn't look great. Thus. This. I think we probably have a little more writing to do. Let's from A, so A. Which is definition of the identity function. Okay, so we prove it has a left inverse. Did we? Use instead of x. Oh, you guys type something. Instead of using x, use a instead of x. Okay, why not? Yeah, that probably might be a little bit easier to make it the distinction. So a, and a. X is an element of big X. Okay. I have a different proof. I'll give my hint with if 5 minutes if you're still struggling. If it's okay with you. No problem, no problem. I appreciate you guys helping, actually. Okay, so let's read over our proof and see what we got. So let G be from B to A is the left inverse of F from A to B. If we have a composite of G to F, that's equivalent to the identity function of A. So we have an A, which is an element. We have a small a, which is an element of A. Then the composite function, which leads to that, thus sends the elements of A to the elements of A, so that we have a composite function that goes from A to A, which is the identity function A by definition of the identity function. Hopefully that's clear. I feel like maybe by definition of the identity function might be a little bit too wordy. Okay, so based on that, we actually did show that the composite. So we actually did show that it is the left inverse in this case. Now we just have to basically show that it is injective. So I think we have to move our ending point a little bit down. So let's move this. Oh, I hate it when that happens. I want to highlight everything. That includes everything in that cube. Yeah, I want everything. Go down. There you go. Okay. So, yeah, we have to write the definition of injective. Okay, so if for all A and A prime, A is so. Now the question is that do we write this through counterpositive or through direct proof? Because I feel like direct proof might be too long. I did my proof by contradiction. Oh, okay. Sends the elements of A to elements of A so that the composite function, which is so now we have to prove that it's an inverse. We actually proved that it is a left inverse. Which is A. Yeah, we probably should. Excuse me, guys. Sorry about that. Okay. Okay, so we got the left inverse proven up here. Now use the definition of injective function. Okay, so let's see. If for all I'm thinking, I feel like I should do proof by counterpositive, but then again, we also have to prove that it's injective. Maybe just doing direct proof might be a little bit less going around, because it seems like when I think about it, it feels like the flow of the proof doesn't go well if I use counterpositive. It seems like it's kind of like going into a massive loop. I mean, writing-wise, when I think about it writing-wise. So, yeah, maybe just direct proof, I guess. A and A prime is an element of A, and A prime is not equal to, A is not equal to F prime, A prime, and F of A is not equal to A, oopsie, F of A prime. Okay. So, now, oh wait, we could just write through proof counter positive. Maybe that will be open enough, so through proof of contra positive, A prime is an element of A, and F of A is equal to F is equal to A prime. There exists an A in A such that A is equal to F prime by definition of a pre-image is equal to, oops, gotta put those parentheses there, equal to F of no, I don't want to highlight all that. I just want to copy this part. Well, actually, I'll just erase it. Let's just erase that. Go down lower. A is equal to A prime. Oh, you guys typed something. Let me just check what I missed. He's taking the negation. You have to show that it doesn't equal A implies it doesn't equal, it's not A and in definition. It's taking the negation. How it changing the form for the definition. The right form is for all A prime from A prime. So it doesn't mean equal. No, it's okay. You're I'm pretty sure that you guys are basically like probably banging your heads a lot because like I'm trying to like do everything that you guys expect of me to write the proofs, and I'm trying to do it in the best possible way so it looks clean. and it actually makes sense, but I'm probably just making mistakes along the way, and you guys are just like banging your heads on the screen. It's like, no, that's not it. It's like someone playing a game, and you know how the game is developing, but the person that's playing it is like, oh, they don't see it. Why don't they see it? Let's see, the negation of B to A is not A and B, but I'm not sure of what he's doing though. Yeah, probably I'm not doing it right. I think it's like whenever like I don't like, I basically follow as if like I'm trying to follow everything in the book. Like that's when it starts to feel like it doesn't feel natural maybe. If you assume that F is not injective, you can get a contradiction. I think for him it's easier to start with the definition. Yeah, I'm trying to start with the definition as much as I can. I think it's because like there's certain strategies on how to attack certain things. Because I'm trying to, because like it's funny because like all the people that are better than me, that basically are like know more about math than I do, like I know they're trying to explain it in the best possible way, but I know like English is not their first language, so it's like I'm trying to follow exactly what they're trying to tell me. But sometimes I don't follow it well, so I have to actually rely on like a book to actually show me some examples. And sometimes I end up using the examples on the book because it shows where, like when I start using it, my brain starts to see where like it doesn't see things. So I'm basically trying to like listen to you guys, but then I'm also going back to the book as sort of acting as a dictionary of a direction where I should go. That's why it seems like my method of trying to solve the proof seems like to be all over the place, because it's like I'm trying to look at the definition, I'm trying to use the definition to write things, but at the same time I know that my brain is not using the definition in a clever way where it will express the proof in a way that actually makes it logically coherent, if that makes any sense. So maybe like I didn't write this right, so oopsie. So let's not do that. Let's not do that then. Because I know the definition is basically, like if we write the definition for injective, the definition of an injective function, all of A and A prime is an element of A is not equal to A prime, and, or maybe I should write imply, implies, F and A, FA is not equal to F prime of A. Yeah, the reason why I wrote and at the and before is because of this structure. I was trying to copy this structure. That's why I wrote and F of A is equal to F prime of A. I was trying to follow this structure. That's the reason why I wrote and in there. Because I thought I had to do that to basically prove that the function is injective. So let's see if we can put this together. No, it's fine. It's fine. I mean, like, you probably like already know how to write the proof ahead of me, because you're already in university and you're already like 2 years into your astronomy degree. So, you know, like, you probably know how to structure the proof better than I am. That's why, like, I'm following everything you're saying, Bennett. No, I am not in university. I'm just studying on my own. I'm just studying math on my own, so it's probably a lot harder. It's probably a lot harder doing it on your own than doing it in university. I'm just doing it to basically like educate myself mainly. Because I want to learn math and physics, so I want to learn how to do proofwriting so I can understand, like, I guess, like the complexities of like basically math, like higher level mathematics. In addition, I also want to be able to use like this math to like basically play with, like, you know, physical problems, like problems in physics. You know, just see if I can play with the universe a little bit. So by definition, so we'll start off with the definition, just like Bennett said. So we'll start with the definition. By definition of the injective function, all of s. Okay, so I feel like there might be a connection if we read the whole thing. So let G be from B to A is the left inverse of F from A to B. If the composite function from G to F is the identity function of A. A is an element of A, then is equal to A, thus sends the elements of A to the elements of A, so which from A to A, which is A. Okay, by definition the injective. Okay, so by this definition we actually have to prove that A is not equal to A prime. Now, I gotta figure out how I do that. Now to show that this definition is applicable to... Okay. So you said you don't have to prove. You start from assume A prime doesn't equal to A in your so since we have okay, so maybe we can write since G of F of A, or maybe we should write the whole thing like so since F of A is equal to G F of A, that equals A. Definition is A is and is not equal to A prime. write that a prime as... Okay. Hopefully that's the way it's supposed to be written. Let's see, let's be... Now since... Maybe I should also write to make it a little bit more concrete. A first year student in uni, and there is a 1 in 4 chance that I get the exact question in an exam this Wednesday. The professor gave a list of 20 questions and he will choose 5 for the exam, so I guess it's a nice problem. Well, I hope this is helpful for you. Actually, like, my mistakes is probably showing you what you shouldn't do. Menton, but hopefully it's my mistakes and my struggles like help you in your studies then, if that's the case. I mean, like, actually I think I have to make this cleaner a little bit, like this bottom part. So let's erase this part, because I feel like this part we can make it cleaner. We can make it thus: g of a of f is not equal to f. I know it doesn't make that much a difference, but to me it just feels like it's a little bit better to write that. It kind of feels like it's more finalized. Therefore, f is injective by definition. I probably didn't have to write that last part, but I just felt like, yeah, why not? Just leave it that way. Just from this, g is doesn't equal, and you have to conclude that f and a okay. Maybe we should just use the arrows, implying that f is not equal to f of a. We'll get rid of this little arrow, little period here. I already solved it this morning, but fun to see how you approach the problem. Yeah, my approach is not that great, though. I will say that for sure. My approach is like, I felt like I was just kind of following along what you guys are saying. I know I have to use the definitions, but I remember when I would use definitions a lot, the one thing is that I don't know how to utilize the definitions. It feels as if when I hear, like, when I read or hear, like, say, use the definitions, it seems to me it's sort of like, okay, write the definition down, and then write what that definition leads about that. But sometimes with proofs, you have to kind of like fiddle around with it. Like, you have to actually, like, you know the definition, but you have to write it in a certain way where it's like you have to try to make it fit with the problem that you're dealing with. And I think that's the thing that I'm not great at. It's like basically just trying to use the definition to my advantage. Because there's some proofs where it's just straightforward, where you just use the definition. Okay, this is the definition, now use it. And then when you just write it down, you then have to write how this definition, what it means, and how it means to the problem. But there are some that basically you have to take parts of the definition and then you have to try to manipulate it in a way where it's like, okay, this leads us to this part of the definition. So, you know. Try to understand why GF doesn't equal GF, means F doesn't equal F prime. Okay, like the way I take it is that the reason why it's like, you know, F of A is not equal to F of F prime is that I'm guessing it's that, basically I'm just assuming that it's like basically taking a different value of X when you think of like a regular function. But that's probably not the right way of thinking about that. I mean, hopefully this proof is decent for you guys. I'll zoom out so you guys can see it better. Yeah, creating proofs is not easy. I will say that for sure. But I'm willing to go through the struggle a little bit. Because I know I'm not going to be like really good at it, but at the same time it's like at least I'm actually having an idea of where I'm going to go forward with it. Okay, so the next one, I think we got to prove it's a right inverse. So F has a right inverse, and F is subjective. Okay, so we have the definition of subjective right here. Actually, it's not only the left inverse implies injectivity, also injectivity implies left inverse is equivalent. It's equivalence, which means it's the same thing. Okay. Let's see. I'm trying to let that sink in from what you said, Bennett. Let's see. That the left inverse implies injectivity. Also, injectivity implies that left inverse is its equivalence, which means it's the same thing. Same thing. Such as the left inverse and the function being injective. Is that what you mean by the same thing, Bennett? I mean, hopefully this looks good. A right inverse implies that F is subjective. Okay. As a right, okay. It's both injective and subjective. Actually, in the book, do they even show you how to prove something is bijective? The pigeonhole principle. I've heard of this, but what does it mean for functions, actually? I've never actually seen it with functions. Let's see, suppose A and B are finite sets, and if A from A to B is any function, if A is greater, I'm guessing that's the cardinality? The cardinality of A is greater than B, then A is non-injective, and if the cardinality of A is less than B, then F is not subjective. That's a funny way of actually defining that. I mean, if you know the function has a left inverse and it's injective, and if you know that if you know that f is injective, it has a left inverse. The strong statement is that f left inverse implies f is injective. So it's exactly what I was trying to say, right? So it's like basically like if f has a left inverse, that implies that it's injective. Hence, if f is injective, then it basically must have a left inverse. But the statement is not in your task. Oh, okay. Yeah, I think it's basically just to show it, I guess. Now that you got the proof, here is another proof I did by contradiction. I assume that there exists a factorial is equal to a prime, such that f of a is equal to f a prime equals b, but g of fa is equal to g of b, which is equal to a by definition of the left inverse. Gf a prime is equal to gb, hence equals a prime. Therefore, gb is equal to a and a prime. Therefore, we have a contradiction. Different a prime, not factor. Oh, okay. Because there's a little exclamation point. That's why I said factorial. Interesting. Like the more you get into, I guess, like into math proofs, the more abstract it gets, and the more you begin to feel as if like, wow, I don't know anything. Okay, so we gotta prove that there's a right inverse, or we gotta show that there's a right inverse. Does Sascha show us a right inverse? Because he did show us the definition of a left inverse. But then again, it could be also part of this definition too. What is this composition? So is right inverse like the opposite, where it's like you haven't I think it's supposed to be the opposite, right? Where it's like you let f be the right inverse of, and then you basically do like from the composition from f to g. So it's like, okay, so let's just write this. F is f has a right inverse implies that f is subjective, or surjective, sorry, not subjective, surjective. Okay, proof. Okay. Let's see. So let f from A to B be the right inverse to G from B to A. How did I write that one? If f equivalent to I think that's how you would show something is right inverse, or like how to find it at least. So, and I'm guessing it's probably the to understand if my proof was right, I'm using ChatGPT. It's helpful sometimes. Yeah, I've been trying to do that too, actually. Like, ChatGPT is kind of helpful at times. Actually, I didn't start understanding certain proofs until I started putting them in ChatGPT. Like, I know ChatGPT doesn't help with everything, but it does get I think it does help organize my thoughts a little bit better, and allows me to see what, I guess, like, people that are more experienced with proofs have tried to tell me or tried to like teach me. But sometimes, like, because like either English is not their not their first language, or they're not using the right words to explain it to me, or maybe they're just trying to explain it to me, but I guess they already have a feel for it that they are not able to explain it in the way that I would understand. So I usually rely on ChatGPT to kind of like, I guess, reformalize what I've learned from the people that do know more than me. Basically explain it to me in a way where I can actually like configure it in a way where I can put it together. I think that's how it is with like most universities, like, because most of the time, like, especially in American universities where you have a lot of instructors that are from like different countries, and they teach, but because sometimes English is not their first language, it's hard for students to kind of like comprehend exactly what is it that they're trying to learn in the topic. And for like even harder topics, it gets a little bit much more difficult. So then that's why in university you end up teaching yourself more, because you have a lot of professors and faculty that are actually from different parts of the world, because they're experts in what they do. Okay, so let's see. I'm mainly talking about this from like, you know, like from my experiences in like the American educational system. So I'm pretty sure like in other countries, like whether it be like, you know, Russia or Japan or Africa, like I'm pretty sure like some students like are not used to their teachers like explaining things in the broken version of their language. Okay, so how do we prove something is subjective in this case? So, subjective. Okay. Maybe right here. The definition of a surjective function every b in B there exists an A in A such that f of A is equal to B, right? Maybe I don't write that. There we go. Actually, I already wrote that. Okay, so that's the definition of a subjective function. So now we got to actually use this. So the definition of a subjective function is if for every b in B, A and what was it in between here? There is an A. There is an A in A with f of A equal B. Okay. So now we got to use this definition here. So how do we prove this one? I think we're missing something in here. So how did we, so this element A, then, so, surjective function is if for every b in B, there is an A with function of A equaling B. Okay. Now, hopefully I defined the right inverse correctly, because I feel like if it's left and right inverse, it's sort of like kind of like the opposite versions of each other. I mean, I hope that's right. Because usually with math, I usually think of definitions if it's like there's a right version or a left version, or like, you know, an up and down version of it. I usually assume it's going to be the opposite in some symmetrical way. Seems correct to me. Okay, that's good. Okay, so by definition, there for every b, so f to b. So let me see. Did I? So should it be? No. Actually, I wrote this wrong. It should be the identity of b. That's why I thought it was funny. I was like, that's not right. It should be like this. I know that's not really like a eureka moment, but it kind of feels like, wow, I actually am not doing this right. There we go. Because I remember if it's supposed to be like the opposite, it's supposed to be like the different version of it. Okay, so we have equaling b. It feels correct. I just have to find a way to write it so it's like, so it looks nice. Well, not, I say look nice, but at the same time, what I mean is that it looks presentable as a math proof. Like it reads, it flows. So I probably should write since f is equal to, which equals b, F is surjective. Now, I don't know if that is a clean way to write it, but it feels like that's kind of like a correct flow of thought for me, like the way it's structured. I mean, you guys can take a look and be the judge. If you feel like there's something up with it, let me know. I feel like that's the way I want things to go, but if it doesn't read correctly or if it doesn't feel like it flows very good, I'm pretty sure you guys will find it. I'm just like reading it over. Oh wait, we have to rewrite this. So it's supposed to be B to B. Lucky I caught that. By definition, da, 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 da. I mean, that feels about right. Hopefully that is the way the proof can be written. Okay, so number 3. What do we have for number 3? F has a left and right inverse. Implies that BF is bijective. Furthermore, the inverse are unique. Okay. I don't know if we have to. I don't know how to prove uniqueness. So, number 3. F has a right and left inverse. Implies F is bijective. Furthermore, the inverse is unique. Uniqueness is usually proved by assuming that there are two objects that satisfy the condition and showing that the two objects are the same. Okay, so it's usually proved by assuming that there are two objects that satisfy the condition and showing that the two objects are the same. So does that mean we have to prove that the right inverse is equal to the left inverse? I'm probably overstretching there for a second. Not sure. I'm also trying to figure out this last one out. Oh, okay. Well, at least you know how to do a uniqueness. For me, I was like, wait, how do we prove uniqueness again? I had to think about it. I have to think about it, and I was like, wait, how do we prove uniqueness? I had to like constantly think. Okay. Okay, proof. So now we gotta think about this one. So proof. Because the thing is, let me see if there's something about bijective in here, because I felt like I saw something that involves that. Oh wait, I'll do what Benap said. So control and F bijective. Interesting. Two sets A and B have the same cardinality written if there exists a bijective function. If no such bijective function exists, then the sets have unequal cardinalities. Oh, that's really interesting. I never knew that. So they so both sets have to have the same cardinalities. That is new. I did not know that. The more you know. Oh, here we go. If A and B is bijective, then the inverse, then its inverse is the function. The functions obey the equation. Ah, okay. Maybe we can use this. We can use this actually. Picture of that. Copy. I think we can use it down here. We don't have to paste it like with the other stuff. Let's carry this over here so it's not too much in the way. Expand it so it's bigger, but not too big. There we go. Okie dokie. I don't know if we're gonna be able to use this, but maybe we should probably leave it there just in case. Okay, so let G from B to A be the left inverse for inverse of f from A to B. That G is equivalent to identity of A, and let f of A to B be the right inverse of G to be that f to the identity of B. Okay, so we have the definition of basically like if A and B are is bijective, then its inverse is the function f, the inverse, which is what G and F are. So they have to obey basically the composite definition, which gives us the identity of the sets that we're working with, both input and output. Now, I don't know if we can write by definition so I think by definition they are considered bijective in this case. The only thing is we have to actually show that they're unique. Uniqueness is usually proved by assuming that there are two objects that specify the condition and showing that the two objects are the same. So we have the process is pretty much like almost similar. It's just that the identities are different. That's actually what's fascinating, is that I didn't realize that cardinality also played a part in functions. I didn't know that if they had the same cardinality, like the sets that have the same cardinality basically means that the function is bijective. At least that's what it looked like it said in the definition. Let me just take another look there. Well, actually, I can just... Where's that definition? No. It's here somewhere. There it is. So what chapter is this? Oh, it's cardinality sets. That's why I didn't know that, because that is actually a really interesting definition, actually. I mean, the definition of bijective is like kind of like fitting with this, like what we displayed here for having a right inverse and a left inverse. The only thing is that I feel like there might be more to it than just basically writing this down, because I feel like we have to prove that, you know, G and F are like inverses of each other. But I think we'll save that for next time. So I guess we'll end stream right now because it's almost time. But thank you guys for joining me. If you like math, physics, as well as like just study streams to keep your guys being productive and studying, or, you know, working on the stuff you need to do on your computer, you know, like if you're watching this on YouTube, like, you know, hit the like, comment, and subscribe, and hit the notification bell so you can be updated on our latest streams or VODs. But if you're watching this on Twitch, you know, like if you like math and physics, or you need like a study stream to keep yourself productive, but you just want someone to be talking to you while you're studying, be sure to like drop a follow to the MathSpellBook channel. In addition, I will also put this in the chat, and for those of you that are watching this on YouTube, I will put it in the description down below, a link to our Discord server. And for my Twitch chat, I will put in the YouTube channel, so you guys can sub there if you like, to check up on my progress in math and physics. And if you want to check out my video game channel, you can also check out my Uncle Talks channel, where I play video games and I just talk to you guys about more than just math. I basically talk about anything there, like, you know, life, or, you know, whether I just like playing the game that I'm playing, you know, that sort of thing. But yeah, that was about it, guys. Let's see. I'm gonna check if we can do a raid. We can probably give more of the math love, the math and physics love. So let's see if there any of our educated friends, educational friends, are going to be on. So FizzBuzz is streaming. I think he's like probably doing something involving computers. Oh no, I think he's like doing some math work here. Alright, so I guess we'll give him a raid. So I will do the raid message for you guys, and I will definitely upload this stream on YouTube, so you guys can copy and paste that if you like. So copy, and then we'll do the raid into FizzBuzz channel. Alright, thank you for joining me today, guys, and always remember, everyone is precious. You guys are just as precious as everyone else, and I will see you guys on FizzBuzz channel. So take care, guys. Bye-bye.